Hey, we have an integral today from the MIT Integration Bee 2017. This was problem number 2. We're integrating from infinity to 1 of ln x over x squared dx. Okay, at first I was a little worried that we have an x squared. We'd like to have, if this was an x in the denominator, it'd be very simple, but it's not. But what I'm going to do is just try the same u substitution and see how it goes. And so what I want to try is making our u substitution just for ln x. And I think because we have an extra x here, we're going to need to find our x value. So just using the property of logarithms, we can say that x is going to be, we have a base e here, so this is going to be e to the u. And then we'll take the derivative here, and so dx is going to be e to the u du. Then making that substitution, we want to update our limits on the integration. So if we plug an infinity into ln x, that's still going to be infinity. ln of infinity is infinity. ln of 1, though, plugging a 1 in is going to be 0. Then our ln of x is going to be u. Our x squared is going to be eu. I'm just going to leave this squared for now because when we do our dx, that's going to be eu du. And so one of these is going to just cancel. And I'm thinking this is a perfect case for integration by parts because when we have u, we have any polynomial, if we differentiate, that's going to reduce to 0 and eventually get us to an answer. Okay, so what I want to do here is integration by parts using the DI method or tabular integration. Okay, so what we're going to do, we're going to want to differentiate our u value and we're going to integrate our e to the minus u. We'll just do alternating signs here. Differentiating u is going to be 1. Differentiating 1 is going to be 0. Integral of e to the minus u is going to be minus e minus u. And then again, doing one more time, we're going to get back to e to the minus u. Because we have a 0 in this last row, we don't have to integrate this last row, so we're just going to take our solution as the diagonals. So then we'll just take our result here. We're going to have minus u, e to the minus u, and then our second diagonal minus e to the minus u. And we just need to evaluate this from infinity to 0. Okay, so let's look at this. So first, doing the infinity part, this first piece is maybe the hardest because, so let's look at this as u over e to the u. If we plug infinity into this, this is going to 0 because the exponential is growing much faster than the numerator. So this piece is going to be, so let's just write this out. So we're going to have 0 minus, and then this term's also 0. So we put infinity in with a negative on the exponential, that's going to be 0. So the first piece is all 0. Then we put a 0 in here. This e to the minus 0 is 1, but 0 is just another 0. And then, okay, so for the last part, we get minus. We put a 0 in here. This is going to be 1, and so we do have a value. So just forget about this, distribute our minus, and we're left with the very simple answer of just 1. So basically, MIT made us do a whole bunch of work just to get 1 for an answer. Anyway, thanks for watching. Please like and subscribe. Have a good day.